My name is Casey McLaughlin, and I've worked at FSU in various capacities and departments for the better part of 2 decades. As the slide says, I'm a longtime Linux nerd, and I've been using it as my primary operating system for over a decade at least. I don't remember how long. Right now, I'm at the Research Computing Center, which is a part of ITS. We are a small team, 8 or 9 people, and we manage the high performance computing cluster. If anybody knows what that is, I don't expect you guys to be in here solely for the purpose of using the HPC, but if you are, I'll try to work some of that content in to the presentation. So just post in the chat window if you have that, if that's your motivation for being here, and I'll try to tailor the content to whatever is necessary. Most of us, 8 or 9 people, use some version or distribution of Linux on our workstations as our primary operating system. And I'll get into the word distribution in a little bit. We're probably going to get too into that at the end of today's part of the discussion. For now, just know that there are several different varieties of Linux designed by different entities and people, and they are all referred to as distributions. Okay, enough about me. We're going to talk about you, specifically what you'll be learning in this workshop. So most of you have specific reasons for being here. So, like I said, some want to learn the basics of the command line in order to use RCC resources like the high performance computing cluster, or you just may want to get an overview of the command line for your own purposes. Whatever your reason, I hope to show you some interesting stuff. So let's dive in. We're going to be covering Linux command line mostly, and operating system concepts, Linux concepts specifically, and of course, later in part 2, we're going to be covering basic system administration. All right, so most of us are familiar with using a computer that has a graphical user interface, or GUI. We're accustomed to seeing visual elements like scroll areas, images, buttons, and charts and graphs, browsing YouTube. You know, that's all graphical stuff. And in a lot of cases, that's exactly what we want for photo editing, document layout, browsing the web, playing games, etc. But not all software requires a graphical interface, especially on servers, embedded applications, and in many other areas. Software runs without this graphical interface, but we still need a way of interacting with a program if we don't have a desktop view to run our graphical user interfaces, or GUIs. They're often referred to as GUIs. A lot of the systems that use it are called servers. You might have heard the term server before. Server software, utilities, and other programs usually only need some text-based information to do what they do. Many of these programs run on a server in a data center somewhere without a monitor, so the overhead of a graphical interface is completely unnecessary. For example, FSU's high-performance computing cluster consists of about 800 rack-mounted computers that operate quote-unquote headless, that is, without any monitors, keyboards, or mice attached. They are stacked very densely in 42 unit high racks. So picture a about 7-foot tall rack with 42 computers crammed into it. They are designed to run 24/7 with high workloads because researchers use them for intense number crunching all the time. Hardware problems are dealt with in this scenario, in the high performance computing cluster, in other words, by using a crash cart, quote unquote, crash cart, which is basically a keyboard, mouse, and monitor on a rolling cart that helps us diagnose hardware issues. The primary way that we interact with these non-GUI programs is through the command line. The command line is a text-based interface where we type commands and direct text-based input and output to the screen, to files, and to other programs. And we'll talk about all of those in detail in part 2, outputting to the screen, to files, and other programs. Today, we're just going to focus on outputting to the screen. All right. The environment we use is called a shell, or command line interpreter, and there are many shells out there. We're going to talk about that later today, but just know that bash, B-A-S-H, or the born again shell, is one of the most widely used shells, and it's the one you're likely to need to become familiar with as you begin your command line journey. Bash is the shell that comes with comes enabled by default with most of the popular Linux distributions. It's also available on Mac OS and in Windows with the Windows subsystem for Linux, which is a downloadable add-on. So I'll be using bash in this workshop. It's also the one I use day-to-day work. If you have a Mac, feel free to open the Terminal app and follow along. I don't know, I guess Michaela or Michaela, I don't know how to pronounce your name, I'm sorry. Michaela, I'm sorry. I see that you're using Mint, and so you can follow along too by opening up a terminal. It's called Terminal on Linux and Mac. Windows users will have to download a subsystem for Linux, and I think I included those in the workshop material notes, but it's okay if you didn't. Just watch, and you can download it later and then try it out on your own time. Okay. There are a few terms and ideas you need to be familiar with in order to be really productive using the command line. Before we jump into using commands, let's take a look at how the command line statements are structured. In general, the general pattern you'll see is executable, options, and arguments. Depending on what you're doing, you might have an executable by itself, or an executable with one or more options, or an executable with arguments only. It just depends on what you're doing and what you want to accomplish. But there will always be an executable. So that's in essence the command. That's the basic unit that we're working with. The executable is the program you're running or the action you're taking. In this first case, it's you'll see ls, which means list. And we'll demonstrate that in a couple seconds. It shows the files in a directory, aka folder. So I'm going to be using the terms directory and folder interchangeably. Technically, it's referred to as a directory, but when I say directory, if you're more comfortable with the term folder, just think folder because they're synonyms. A lot of executables you see are very short, sometimes just a few letters. This is a tradition that goes back a long time. Many executables are just long enough to represent what they mean rather than using the whole word because programmers are lazy. While it can take many while it can make commands a little harder to remember and discover, as you'll become more familiar with the command line, you'll see how it is a lot more convenient to type short commands like ls every time you want to list the files in the folder instead of typing out list or list files or something longer than that. Sometimes a command does something just by itself, but other times we'll want to change how a command works and tell it what data to use. So we tell it what data to use in an argument. And so this example, ls, means list the directories in the home/fob directory, or list the files rather, I'm sorry, files in the home/fob directory. All right. The next part of the command line statement, the options, tell the command how to operate, changing the behavior of the command or telling it to perform different actions. We'll see some examples in a moment, but here the option -1 is instructs the ls command to print all the items on each individual line, each item on an individual line, rather than the default output. And we'll see what that means in a minute. Also, I'm using the --all, and that just means to show hidden directories and files and stuff like that. And we'll we'll see what that means in a couple minutes too. The other point to make about options is they almost always start with a dash. And I say almost because in a messy environment like Linux, there are instances where the rules get broken every now and then, but 99% of the time, it's an option if it starts with a dash. So that's an easy way to differentiate options and arguments. Options almost always start with a dash, and you can usually tell from context if what's an option and what's an argument if they don't. And then arguments never start with a dash, unless, well, never say never, but most of the time they don't start with a dash. Also notice that one-letter options mostly use a single dash, like the -1 that we have on the screen here. But most of the time, whole word options start with 2 dashes. So -- all. And likewise, most full word options have a single letter shortcut, single character option. But that's not a hard and fast rule. Nobody dictated that in designing Bash. So you're going to find situations where that's not always true. But like I said, every rule has its exceptions. Also, most commands like the one here, ls list, have more than one option. And so when you need to use more than one, you can list them individually, and the order does not matter. So I could reverse these, flip these, -- all, and then -1, and it would produce the same output. Okay, let me refer to my notes here. Okay, yeah. So the last portion of a statement is the argument or arguments. You can have more than one argument, and some commands take more than one argument. So just know that. This is where you tell the command what thing to operate on. It's usually a file path or a set of files or folders. In this example, we're telling the ls command to show us the contents of the folder home Bob or directory home /Bob. And that's it for basic commands. Just know that there's always an executable. Sometimes there's options, and most of the time there's arguments. And there's all kinds of exceptions to these rules, but you don't have to worry about them for the basic stuff, which is all we're going to be going over today. Now that we have the basic structure of commands in mind, it's time to put our newfound knowledge to work. So I'm going to close my presentation here for a second, and then I'm going to open up ood.rcc.fsu.edu. So if you are familiar with the Research Computing Center, we recently launched in a tool, I guess I could say, to make the HPC more accessible to a wider variety of users. And you don't have to necessarily know the command line to use the HPC now, but it would help, it helps. Since our presentation is on the command line, though, I'm going to open it up here today. So OOD, if you have an RCC account and you're connected to the VPN or on campus, you can go to ood.rcc.fsu.edu in your web browser and log in with your RCC credentials, and then go to clusters and HPC shell access, and it'll open up a new tab, which I'll be using to demonstrate concepts today. Okay. Okay, so we're going to start with a few basic commands. Who am I? What does that print out? and I'm used to interacting with a room full of people here, so this is weird. But I usually ask, hey, what does this print out? But in this case, I'm just going to tell you, it prints out the username that you're currently logged in as. And you can see that this is kind of redundant in this shell because the username is already available. And we'll talk about the prompt here in a few minutes. But for now, just bear with me. Let me see. Okay, so speaking of the prompt, what is the prompt? So the first thing we see in the shell is the prompt. It's called the prompt. And the prompt string shows a little bit of information. In my case, it's my username at my host name. So my username is camo2h and the at symbol HPC login-24. And if you try to use that as an email, you'll get bounced back. It's just, this is not an email address, even though it looks kind of like one. It's the, in other words, it's the server's name, which I'm connected to. Right now, also included in the prompt is this tilde symbol, which represents my home directory. So if you keep in mind when we get into files, probably on day 2, that the tilde means home, you'll be ahead of the game. Now, depending on which platform, Linux version you're running, this prompt may be different. But one thing is always constant. That's $sign and a cursor. Sometimes the cursor is blinking, other times it's not. Just know that you can type commands into it like that. Okay, so let's run a command. Who am I? You know what that does? Let's do the list command now. And you can see that it outputs the contents of my home directory. Okay. Now we'll add an option here, ls-1, and see how what it does. It prints everything on its own line. So that's particularly useful in some cases. You want the output to be on a single line, but we'll get into that when we get into piping in part 2 of this workshop. Let's try out some other commands. Host name. Okay, that prints out the fully qualified host name, hpc-login-24.rcc.fsu.edu. That's pretty much all it does. Date prints out whatever the server thinks the date and time is. Cal, this one's kind of cool. Prints out a friendly calendar. Today is February 2nd. DF, okay, this is an interesting one. It prints out in this weird hieroglyphics about how much storage is used and available on your system. And when you scroll back up to the top in your terminal emulator, you can see kind of hints at what it does. The file system, 1K-blocks, used, available, use percent. Okay, that's pretty much the only intelligible part of this output if you're not used to it. But we'll find out how to make this more user-friendly in a few moments. Free, let's try free, okay? Again, what do you think this command outputs? Give you a second to look at it. Go ahead, Michaela. Yes, it tells you the total memory, the used memory, and the free memory, including some more details. But it does it in a non-user-friendly way. Now, this is kind of like 620, 757, 65,757,620 what? You know, I would assume bytes, but it doesn't say. Also, if you type exit, it'll just close the terminal, which I'm not going to do, so because it would kill my session. But anyhow, these are some examples of the many thousands of commands available. So now we're going to add some options to them. So next slide. So if we print out cal-j, we run the command with the option J, the cal command with the option J. Notice what it does. Can anybody tell me what it does? Again, I'm so used to being in person, teaching this in person, but it prints out the number of days since the beginning of the year. So this is the 33rd day in 2021. Date-R, let me see what that does. And I should take a moment here to say date-R is not the same as date-r. Linux is one of the few operating systems that is case sensitive. Well, actually, let me take that back. It's one of the many operating systems that are case sensitive. I think Windows, and I don't know if Mac is or not. I think it is, but both of those are case insensitive, if I'm correct. Linux is not. So if you're using Windows or Mac, just know that the uppercase, lowercase difference is important in Linux. Okay, so date and date-R print out slightly different versions of the date. Again, this only matters, these details only matter if you're sending the output to a program instead of the command line, or if you have a preference, you know, whatever. Let's do df again. So df without any arguments, just print out this nonsense. But df-h makes it a little bit more legible. So we have 20 gigabytes. Used is 17 gigabytes, and available is 3.7 gigs. So right off the bat, we have indicators or measurement units here indicating how much space is actually available versus this output, which is like, who wants to do that math? All right, so you can kind of see how our options change the way a program runs. df-h --total, so df-h-total. Notice that I'm using double dashes for the complete words and single dashes for the short codes. That just prints out an extra line at the bottom saying how much space in total is available. In this case, it's 1.2 petabytes. How much is in use? I think used, yeah, 734 terabytes, and free is 415 terabytes. So across all the file systems on this computer or server, we have this amount used and free. Okay. All right. Now, notice that this, we know what the option -1 does. It prints out each item on its own line. But now I've added an argument. So let's see how that works. So ls, without any options or arguments, prints out that. Okay. ls-1, without any arguments, prints out that. ls-1 etc, prints out some other output. Also, I'd like to pause here and note that while my output contains pretty colors, you can't count on that being available. I don't remember if Mac OS X has that enabled by default. I think it does, but a lot of times you'll just get gray here. So if that's what you're seeing, don't worry about it. The colors are just a feature of the particular distribution of Linux I'm using. Okay. And then one thing to note here is that short codes as options can be lumped together. So ls-1 capital A/etc, whatever. I think that the only difference between that and the prior output is that the A, capital A, I think, shows hidden files and folders. And you'll know a file is hidden because it will begin with a dot, like that. If we go back to the prior output, notice that it is not in the list. Okay. Any questions at that point? Okay. Let's resume the slideshow here. All right, so the question is, how do we know what to type? And unfortunately, you can't hold every Linux command in your head. So if you see a veteran Linux user typing away at the command line, or you see a snippet of bash commands in a tutorial online, it can seem like mesmerizing the ins and outs of commands and options is the only way to be productive, or memorizing, sorry, the commands and options is the only way to be productive and understand what's going on. But everybody starts somewhere, and even experienced command line users, like this guy, don't memorize everything. So it's just not practical to try to memorize all of the syntax and options on the command line tool. Of course, it's important to remember the basics, but while you're getting started, you only need to remember a few commands. This is a real t-shirt, by the way. If you know who the XKCD guy is, I'm sorry, you're a nerd, but this is a t-shirt with a reference for Linux commands printed upside down. And unfortunately, it's sold out on the XKCD web store. All right, so getting help with commands. So fortunately, Linux has built-in documentation, and it's not special attribute to Linux, but I'm glad it's here. So we'll look at how to access that now. Oh, Michaela asked for the website URL. So if you go to that website and look for the store link on the page, it'll take you to the merchandise section. Okay, so the first is the documentation is what is. That's a simple one to remember, and it will be useful. So what is display manual page descriptions, and what is ls? Now, I don't know why it prints out multiple lines, redundant sometimes, but it has to do with some technical arcane thing that is built into Linux. Just know that if you get multiple lines and multiple explanations, usually if they don't contradict each other, you can use them. And I've never seen two that contradict each other, so or output from the what is command that contradicts itself. So what is df? Report file disk system disk space usage. What is cal? Display calendar. What is well, et cetera, et cetera. So you can do this with most commands. Sometimes if you install custom software, especially software that was hacked together by scientists, there is no manual for it, which is why we are employed at the RCC to decipher what software scientists have written. But I'll just create an example here, or show an example here. What is RCC tool? That is a command that I actually wrote, and as you can see, it's got no manual page. So I'll show you how to get useful information about the RCC tool in a few moments. The thing about the what is command is that it doesn't supply any information other than a one-line summary. In most cases, 2 one-line summaries. We need more robust built-in documentation. So I'm going to show you the next one, which is man. That is not a sexist command. It stands for manual pages. You can think of the man pages as technical reference book for your Linux distribution. If you know the name of a command, you can find out a wealth of information about what it does, what options it provides, what arguments it takes, etc. And to look up man, and we'll man ls here. So just type man and the command you want to look up, and you get this. I'm going to go over this page with you real quick. Every manual page has a few common sections. So the name and what it does in plain English. So list directory contents. The synopsis section gives you a brief example of usage. So ls really doesn't have much more than the basic command structure here. It takes multiple options and multiple arguments. You know that it takes multiple because the option is in brackets and it's got a ... etc. symbol after it. All right, and then you get into the meat of the manual page. List information about the files, the current directory by default. So if you don't type an argument in, it'll just list the current folder or directory. Sorts entries alphabetically if none of the whatever options or sort is specified. Mandatory arguments to long options. Mandatory arguments to long options are mandatory for short options too. Okay, that's just boilerplate. And of course, now you get into a reference of all the options you can use in this command. And you can see that it's evolved into a kind of monster command. So, and every single one of these options was put in at a later date by somebody because they needed to accomplish something very specific. And finally, the next section, I think the next section, okay, description. Yeah, okay. When you get to the bottom, you get attribution information about it, but you'll know you're at the bottom because it'll say end. And then it'll press H for help with this interface or Q to quit. So, and when you quit, it dumps you right back on the prompt. We'll check out another one, cal. Okay, display a calendar. So it's got the same information, just with different content, cal. And then takes a few different, the syntax of the command is a little bit different, but it's pretty much the same. Again, these are the arguments, and it does accept options. And as you can see, those options, a lot fewer options are listed below. So, and it generally defines the default options if you don't supply any options explicitly. So it displays 1 month. So whether or not you run it like this or run it like that, it always produces the same output. But you can give it an option, -3. Oops. Yeah, I thought that was right. Oh, sorry. Cal -3, and it gives you that output. And of course, we don't need to get into all these options, but just know that the manual page is there when you want to try it out. Okay. Let me see where we're at. Okay, occasionally you'll come across a command that takes no options, but that's fairly rare. There's a whole lot of information in the man pages, which you can navigate with the arrow keys up and down, or you can page through it with a space bar. When you get to the end, it'll just display this message rather, and then quit. Okay, any questions at this point? I use Redshift, but can't figure out how to change the preset hours for the local setting. I think it's set to CST right now, not East EST. There's a note to change it using a small file. Any suggestions on commands? Okay, I'll tell you what. I will deal with that, Michaela, outside of the scope of this presentation because it's way outside the scope, but I promise I'll answer it offline for you. Okay. Also, most commands, and this is not true in every single case, but offer a special -- help. Oh, if you have to leave it 4, then you can just email me. You can find my email address on the RCC website, rcc.fsu.edu. All right, so getting back to the presentation. Most commands offer a help, a brief summary. And this is not always true, but it's true for 99% of cases. So ls-help looks like this. The output is, the synopsis is the same. The summary is condensed down into 1 or 2 lines. And then you can kind of see that it's got a quick reference here for all of the options and arguments it accepts. And if we run ds-help, I'm getting caught up here. Yeah. So again, df options takes files as input, and then these are all the options that are available in this command. Now, earlier we ran it with --h, which the long form is --human-readable. But notice that it's got an uppercase H option too, and that does something similar, but with powers of 1,000 instead of 1024. And that's important because sometimes you want powers of 1,000, and sometimes you want powers of 1,024. This depends on what you're doing and what the outcome of your motivation is. Okay, and then of course I used RCC tool as an example of where you couldn't use the manual pages in any regard whatsoever, but it does have a help. And it's got pretty colors and everything. So that is when you don't know, you can't find any manual page, just append --help and see if it has a help section at least. Likewise, ls version --version comes with most commands as well. So, and it just gives you the version number and the attribution information. And then of course, oh yeah, I wrote that. Okay, any other questions at this point before we move on? All right, I'm gonna take a quick break. Okay, let's take a moment to step back and gain some perspective on this, all of this. I'm gonna restart my presentation. Okay, so if you have a Mac, you may have been able to follow along with most of these in your own computer because Macs are very similar to Linux. In fact, Linux was derived, or I'm sorry, Linux co-evolved with BSD, an operating system called BSD. If you Google it, It's going to be very similar to Linux, but a couple structural changes, I guess. I don't really know the difference between the two, but I know that Apple based their recent operating system line, OS X, off of it. I guess I shouldn't say recent because it dates back to when I was in college. But Apple, BSD, and Linux all follow the same standard on their terminals, which is called POSIX, Portable Operating System Interface. And it's an IEEE specification for maintaining compatibility between OSs, operating systems, that is. And POSIX systems have very similar shells. So remember that concept of a shell and a prompt that I mentioned earlier that I showed you guys. That is, if you get on a Mac and open the terminal app, it's going to be pretty much the same as a Linux because it complies with the POSIX standards. And you can Wikipedia rather this POSIX standard and learn all about it. Interestingly, the one exception is Microsoft Windows because it evolved in a parallel universe. But even they have sensed where the software world is heading, and now they include a free Linux subsystem that shunts a copy of whatever your favorite Linux distribution is into Windows. And again, if you are interested in looking into that, Windows users, I will be happy to share that with you. And, but just Google Linux subsystem for Windows and you'll find it. Okay, let's talk about operating systems in general now because I think that's pertinent to our discussion. So all operating systems share some concepts in common, even Windows. They all have the same basic architecture, which is a good thing because that means you can install any one on your computer and it will work, barring licensing restrictions. And I'm looking at Apple mainly for that because Microsoft, while it's not POSIX compliant, it does have a lot more liberal licensing terms than Apple OS X or whatever they're calling it these days. Okay, so let's start from the bottom and work our way up because that's things get more abstract on the way up. At the very bottom is the hardware, which is the tangible parts of a computer, the CPU, the RAM, the disk drives, the display devices, input, output, etc. Every operating system has a part that interacts with the hardware, and it's called the kernel. This is a universal term used across all operating systems. When you hear kernel, think about hardware interaction part. It refers to the core of the computer's operating system that is always resident in memory. Its main job is to interact with the hardware. What I mean by always resident in memory is that while you may open and close applications while you're using a computer, this is the part that remains constant in the background the entire time. Okay. Normally, you don't have to worry about the kernel because we always interact with the kernel through a shell. So unless you're a kernel developer working at Microsoft or Mac or Apple or contributing to the Linux system, you never have to work with the kernel directly. Instead, you'll work with the next layer up, which is the shell. This is the part that the user human interacts with, you, the human. If you're using Windows or Mac or any OS created by a commercial entity, you usually get one shell and that's it. Which if you think about it, it's fine. You want the user interaction with the operating system to be as smooth and effortless as possible. So why would you want a company that's intent on making money and to bisect its efforts in designing the best interface that they can? Linux, on the other hand, has a different development model, which we'll get into in a moment. Suffice it to say, it's a lot messier, and there are many shells competing in the marketplace of ideas. You can see some of them listed here in this slide, but there are hundreds of others. So the ones listed in the slide are C shell, K shell, Bourne shell, which is named after, I think, somebody's last name. And then there's also Z shell and a whole slew of others. And those are just the command line ones. We haven't even gotten into the graphical ones yet. Some graphical shells, there's some, let's see, yeah. Some shells are graphical or GUI, like we saw in the, one of the first slides I showed you, but most are command line shells because the majority of Linux systems are used in specialized environments like the HPC, but where they don't need graphics, and that just incurs a lot of overhead, and you want those systems to be as performant as possible. But almost every major Linux distribution that you can download has a desktop version that is installable. And so, in fact, I'm using Linux to do this presentation on. This shell is called the Gnome Shell, and it presents pretty much all the advantages of Windows and other and Mac, but it's the primary difference is that I didn't have to pay for it. I just went down and downloaded it, and it was free. The two most popular shells are also the longest lived ones that are GNOME, like I'm using on this computer. But there's also one called KDE, and as a matter of fact, there are dozens of others. I think somebody said, Michaela, that you're using Mint, and I think that the desktop environment on there is called Cinnamon, I guess. I don't know. I've never used it, but
hey, Casey, it looks like Michaela's asking why.
No, I think she's saying yes.
Oh, okay. Never mind. Sorry. My bad.
And the nice thing about Linux is that you can download a copy and tinker with the code, which is where all these alternatives come from. But we'll get into the more details about that in a second. One more thing about shells is that you can switch them while the computer is running. But normally you wouldn't want to do that. You have your favorite, and whether they're GUI or CLI shells, you tend to have one that you find yourself most productive in. Like I said, in this presentation, we've stuck with Bash because it's the most popular and also comes pretty much on all distributions by default. It is kind of a funny name though, because it's short for Born Again Shell, which is a play on words. I find that amusing. Finally, getting back to this diagram here. So we have the hardware, we have the kernel, which is the core of the operating system. We have the shell that kind of wraps around it. And then finally, we have the top of the hierarchy, which is the user/human. And I would discuss this level, but since I'm not an expert in human psychology, I'll abstain for now and steer us back to the technical stuff. Okay. So let me see how much time we're at. Okay. Oh yeah, we have time for getting into files. Okay. So before we move on to file operations, I would like to take a moment to clarify something else about Linux, the technical meaning of a distribution. This involves getting into some history, so bear with me. Back in the olden times, the 90s, specifically September 17th, 1991, according to my notes, a man in Finland named Linus Torvalds, I don't know how to speak Finnish, but released the very first version of Linux in an attempt to create a fully free operating system. Okay, so not only did he create a free operating system that was free to use, it was licensed under the General Public License version 2, which, if you're interested in legal stuff, is very fascinating how this license is structured, but just Wikipedia it on your own time. But it's absolutely a fascinating story that we don't have time to get into today. But one of the main provisions of the GPL is that you're not only free to distribute the program, but furthermore, users can tinker with the code as much as they want, creating their own distributions and, of course, distributing them. And that is core to the idea of the free software movement, which was started back in the early 80s by this man named Richard Stallman, who we don't have time to get into that guy, but he's definitely an interesting character. And the reason Linus Torvalds chose it for Linux was because it was such a permissible license that it was appropriate to for the objective of creating a free operating system. Interestingly, Linus Torvalds still maintains control of the source code for the official Linux kernel 30 years later. You may recall from earlier that the kernel is part of the operating system, right? This part. The difference between Linux and commercially developed operating systems, besides it being free to modify and use, is the development model. Linux is not developed by any one company or institution. Rather, it is collectively worked on by millions of developers all over the world. At the center of this web of activity are the core maintainers deciding which changes to the kernel get accepted into the official kernel. It's certainly one of the bigger collaborative efforts in humanity that humanity has undertaken. As with any giant worldwide collaboration, there will be differences in opinion. And so the GPL allows, and as some would say, even encourages that. And so this slide shows the evolution of Linux. So while Windows and Mac OS follow a fairly linear development pattern, straight lines, in other words, the development of Linux looks a little more messy. And I see that Michaela has asked that, was Red Hat before Linux? No, actually, it is one of the earliest Linux distributions, which we'll see in the slide in a second. If this looks like something you've seen before in the biology class, it does to me too, because you'll see some similarities in that most distributions today stem from a few main branches that have been around since the beginning. The difference in Linux is that those branches are still around and haven't been extinct yet. Most of them, at least. The thing that makes these distributions all quote unquote Linux is that they share the same kernel. So they're all shells, or sorry, there's actually a hidden layer in between the shell and the kernel. It's called the user space, and they're all pretty much user space implementations. Come on. Wrapped around the kernel. Let me see. Yeah. Okay, so the kernel is the only thing that follows a linear development pattern like those corporate operating systems I mentioned earlier. But we need constraints to innovate. You can't innovate without any rules. So there's the main difference between the commercial operating systems and Linux is that in the case of commercial software, those constraints are decided by a single entity or institution like Microsoft or Apple, etc. Linux, on the other hand, is developed, argued over, and packaged by developers all over the world. There are several core maintainers, I guess they're called, but Linus Torvalds still has the final say of what makes it into the kernel. Now, you're free to deviate from his opinion, and a lot of people do, but then you can't call your software Linux. You have to call it something else, which a lot of people have. Let's take a look to explore this slide real quick, because I think it's pertinent to this discussion. So going back to the beginning of the Linux kernel, which was 1992, and fast forwarding to today, which is 2021, you can kind of see that a whole hell of a lot of distributions were made, each one of them trying to solve a different specific problem. Now, there are three main original style user space implementations, and one of them is called Slackware. And of course, some of the earlier branches petered out, went extinct, I guess you could say. But the main Slackware is alive and strong today. I just lost my cursor. I don't know what happened to that. And the next granddaddy of them was called Debian, and that is also alive and strong today. Somewhere on this tree of life, Ubuntu emerges around 2008, I think, no, 2004. I'm not going to try to find it, but and then Ubuntu spawned a lot of its own. Here it is, Ubuntu, way down here. Let me see if I can fix the mouse. And then Linux Mint, actually, that Michaela is using, is derivative of Ubuntu. And it's listed here somewhere too. Finally, the third major distribution was Red Hat. And the difference between Red Hat and these other distributions is that Red Hat was in it to make money. So the GNU license, GPL license, doesn't specify that you can't use your the code in commercial products, which a lot of people do. So Red Hat was the first major company to try that, and you can see here that they started Red Hat Enterprise around the same time Ubuntu was created, and they actually sell it to institutions. I think FSU actually has a license, but we use a derivative of Red Hat called CentOS, which oh wow, yeah, which is a bug-for-bug clone of Red Hat, just licensed differently and stripped of all the trademark and copyrights and stuff on the HPC at the RCC. It's interesting stuff. And now that you have a little bit more of a better idea about what this Linux ecosystem looks like, we can move on. But just know that also there's been a lot of other startups that petered out or are still going. And these all, like I said, these all purport to solve different problems that their creators had. Android solves the problem of shoving Linux on a phone, which, and it's developed by Google. But as you can see, because it's open source, because it has to be licensed under the GPU license, or GPL license rather, sorry, it's free to change and tinker with. So this is where we get all this stuff, these branches from Android. Okay. Anyhow, while we still have a half hour left, I think we should dive into some technical stuff. So we'll close that tab and that tab, and return to the operating system. All right. So one thing that you'll see me type from time to time is clear, which clears the screen. Clear. Okay. All right. Also, if you noticed, I wasn't appearing to type commands the second time I ran them, because up and down gives you a history of what you previously typed. And it saves the last however many commands, I don't know, a lot. And this is totally configurable too. If you want to change the history length or disable the history for security reasons, you can per account. Also, you'll see that the tilde refers to your home directory. It's a short code, and we'll see about moving around the file system in just a minute here. Finally, echo just echoes your output, whatever you want to say to the terminal. And we'll find the usefulness in this when we get to piping the output of a command to another program. Okay. Also, if you remember what the first couple characters of a command are, but you can't remember exactly what the command is, let's say we can't remember the cow command. you can just type in CA and then type tab, and it gives you everything that, all the commands, executables that are start with CA. And so, oh yeah, cow, right? So, and you can do that for every command. So, you know, if there's a lot of possibilities, it prompts you whether or not you want to display them all. But just know that you can use shortcuts like that. And I mentioned that early on in this presentation because I will be taking some of these shortcuts, and I just don't want you to make sure, I want to make sure you guys don't think I'm copying and pasting these commands in from another source. Not that there's anything wrong with that, but no, I'm using short codes. And there's a ton more, but I'll try to refrain from using them. Okay, back to the presentation. We're going to talk about files now, and then I'll wrap up in about 20 minutes. Okay, so if you're using Windows, you kind of need to be re-educated on this because Linux and Mac approach file systems the same way, but it's completely different than the way that Windows does it. So Windows assigns a letter quite intuitively to each physical device, storage device. So, you know, each of these represents a single disk or partition that you can take out of the computer and hold in your hand. So C, D, E, F, and H. So these are all hard drives, and like I said, with very few exceptions, these represent physical devices. So if you plug a USB drive in, Windows automatically assigns a letter to it and, you know, whatever's available, and you can interact with it using that interface. Likewise, with CD-ROMs or DVDs or Blu-rays, if you have optical media, it assigns a letter to the drive that reads that too. Everything gets a letter, okay? Including network map drives. So we have a drive on a network, you might refer to it as the K drive or the I drive. That's very intuitive, but unfortunately, it's not the way Linux and Mac manage systems. So Linux, the primary place where the operating system is installed, the physical disk where the operating is installed, in other words, is called the primary mount, okay? And so it always has the slash. So, and we can actually look at this in the system. So ls/, okay? So I'm going to give it the list command and tell it to list the contents of the root file path. So that is the primary mount right there. And you'll notice that all the directories in it, the directories are denoted in blue on my terminal, so just know that. All the directories in it have arcane names, and we'll get to that in a minute. However, let's say we have a second hard drive in the system, and what we need to do is mount it, which involves creating a directory and then manually running the mount command. So mount the file system. And you can read file system as a virtual partition, a physical disk, a CD-ROM, a USB stick, whatever. And of course, if you want to get further help with it, there's all kinds of information here about the mount command. And then mount-help, a shorter version of the man page. Okay. That goes for network mounts as well. And so here on the HPC, we actually do mount a file system, and it's called GPFS. So mount without any arguments just lists the mounts. And it does so in a arcane way that's barely readable. I mean, you have to be an expert to even understand all this. So I prefer to use the df command with the -h to see what's mounted on the file system. So a lot of temporary file systems. So we'll scroll up from there, and you can kind of see, okay, wherever the root is, it'll say / for mounted on. And in this case, it's the device SDA1. And I should mention here that everything, almost everything at least, in Linux is denoted by a file in the system somewhere, including devices. And that's not only done for consistency and convenience, but it makes managing a lot easier too. So this physical disk has 20 gigabytes. It's 20 gigabyte size. We've used 17 of them, so 3.7 or 82% are available. Okay, and it's mounted at the root. All right, now we have a separate device. /dev is the directory or folder that all the device files are kept in. This represents another physical disk in the system. It's also 20 gigs, and it's mounted at temp. Another physical device mounted at var, and finally a third, much larger drive mounted at opt. Okay, and finally, GPFS home and GPFS research are two components of the GPFS file system that we sell to users. And of course, this is almost astronomically sized at 948 terabytes, almost a petabyte. And you can see the research partition is 3/4 full, whereas the home directories are 15% full. So if you have an account on the RCC or HPC, we give 150 gigabytes for free as part of the allotment that you automatically get in order to manage space efficiently on the system. If you need more than 150 gigabytes, you either have to beg us, staff members, for additional space or purchase some. Most research labs purchase some. Okay, so if you get stuck and want to know how much space is on your system, and most computers have a single drive. So I'll pull up another terminal and run the same command on that. And ignoring all those loops, so this computer has a 500 gigabyte hard drive, 467 of which are usable, and I'm using 34%. But notice that I found the / entry under the mounted on column, and that's what I'm referring to get the actual free space on my system with a single hard drive attached. Okay, exit. We'll close the window. Okay. All right. So, understanding that everything is a folder / directory, regardless of what physical devices, network devices, USB devices, whatever, optical media included, needs to be at in a specific folder or directory on Unix-based systems, or rather, I should say POSIX-based systems. You need to, and I won't get into how to mount those, but because that's outside of the scope of this presentation, and fortunately, it's documented to death on the internet. So just Google mounting devices on Linux if you ever need to do it. Okay, so we're going to get into, in our last 10 minutes, some ways of moving around the file system. Okay, so clear this. All right, so the first command I'm going to show you is pwd. Okay, what is pwd? Print the name of the current / working directory. That means that the directory that the context of which your terminal operates is open in, and or your current working directory. Just know that's where you are located in the file system. And most of the time when you log in, you get dumped into your home directory, which is where I am. So gpfs /gpfs /home/camo2h. Okay. Okay, so we can move around the file system by the change directory command. Change the working directory. Okay, so let's say I want to go all the way back up to the top. So change directory /. Now you can kind of see here that the prompt has changed. Okay, no longer does it have this tilde, but it has the /. And then when I do type in pwd, okay, and let's do a listing of this directory. And you see that it's the same as if I provided the an argument for this at the end of the command. It produces the same output. All right. Now, let's say I want to go back to my home directory. So my home directory is located here. So change directory /gpfs /home-camo2h. And you see it changes to that tilde again. And if I do a list in here without any arguments, it prints out the contents of my present working directory, which is my home directory. However, if I add an argument, it prints out whatever I want. Not to beat this to death, but I just want you guys to understand how this works. So I'm going to go back up to the top, clear the screen, do another ls, and let's dive into one of these subdirectories. We'll try etc, okay? So there's two ways to get to move around the system, absolute paths versus relative paths. And I'm going to go over what each of those terms mean right now. So absolute path always starts with a /. And then you type the directory name and hit enter. Okay. Now, / is an absolute path. But /etc is also an absolute path. All right, and let's do an ls in here. All right. Wow, there's a lot of files in here. etc is kind of like the control panel for Linux, the equivalent of the control panel, or system preferences on Mac. But it's the Linux version of that. So, and I probably won't have time to get into administration of Linux systems in this presentation, and it's kind of outside of the scope, but I'll point you towards some resources if you do. Now, let's take a look at relative path navigation. Change directory. All right, relative path is when you want to go into either a subfolder or a parent folder of the directory you're in. So relative paths don't require a / at the beginning of them. You can just type in etc. And since I'm in the root path, I just had to type in etc. Now, I can navigate there, teleport there instantly by giving an absolute path, but I can move around the system relatively too. So we'll do a listing, and let's try another, a better example. So all of these things in blue are directories. So let's go into the sysconfig directory. So now, if I was going to try to go into the sysconfig directory using an absolute path, I would type this command. But since I'm already in the etc directory and the sysconfig directory is one level beneath the etc directory, I just type in space sysconfig. And let's do an ls in here just for kicks. I don't know what those all are, so we're going to ignore them. let's say I want to go back into the etc directory. So that is denoted by 2 dots, dot, dot. And that takes you up a level. And then ls, and we are back. Dot, dot, ls, we're back in the root. And of course, if you try to do it from root, it just, there's nowhere else to go. So it doesn't do anything. Questions? Okay, we have about 5 more minutes here. So let me just show you a shortcut. Say you're in the etc sysconfig directory or somewhere else on the file system, and you want to teleport to your home directory. You can either type in home ppfs k12h if you know that, but you can also just type in a tilde, because that's shorthand for home. And I'm back in my home directory. Now, on the HPC, you're probably going to do 95% of your work in your home directory. So all this moving around outside of your home directory is just for demonstration. In fact, most users don't have permissions to see anything or edit any files outside their home directory. But I want to go into the bin directory. And so I'm going to just type in the relative path because I'm already in my home directory. And then let's do an ls in there. And there's a bunch of files. Notice that they're green. So we'll get to that in probably next week, or this Thursday rather. But I want to show you one more command, the list command with the -l option. All right, and gives us a lot more information about the files in addition to listing them on a single line. So these are the permissions, and I'll tell you how to decipher this string of characters on Thursday. But just know that, or you can Google it either way. And of course, I'm the owner, and so this column, I forget what it means. I honestly can't remember. But the next column is the owner of the file, and then the group that the file is in. So we have this concept of groups that allows you to share data. This is the size in bytes of the file, and this was the last modified timestamp. And this is the name of the file. So permissions, owner, group, size, last modified, and finally the name. All right, now let's do a ls-etc. So we're going to list the contents of the config file folder. Oops, ls-l etc. All right, notice that most of these files are owned by root and have the root group root. This is the permission. And some of them are green, but most of them aren't. Okay. Now, occasionally you'll see something like this. And that is called a symlink, S-Y-M-L-I-N-K. And that kind of operates like a shortcut. This one is broken, which is why our system administrators chose to put it in blinking and color it red, because it needs to be fixed. But it's typically a file that points to another file. Here's a working link, symlink rather, init.d points to rc.d/init.d. And notice that even if I didn't have these colors, I would know that this is a link because this first column here has a dash for regular files, an L for links, and a D for directories. So that's a neat way to determine if you are dealing with what type of thing you're dealing with, even if you don't have colored output. Most distributions come with colored output by default, but some don't. Just depends on how arcane and technical your distribution is. Okay. All right, so notice that this command lists the contents of GPFS home, and you see all the users there. So this is a nice way to see who has accounts on the system, HPC at least. Most of these have private permissions. In rare cases, people want to share their data with other people, and so they open up subfolders or even their home folders to use. But most of these you can't access because, well, that would be an invasion of their privacy. All right, let me see. I think this is a good place to leave it for today. This Thursday, in part 2, we are going to go over a quick tour of the Linux file system. I'm going to give you a brief review of everything we covered in this day, and then we're going to learn some other concepts, specifically manipulating files, text editors, and piping output, and that's probably all we'll have time to get into. I'll go over getting stuff from the internet too, but I think I'm going to call it a day. Any questions? Okay, well, you can stop the recording and I'll see you later.